Welcome to Conceptual Cambridge. This is part 2 of the differentiation series. Today we are going to do increasing and decreasing functions. So let's begin. So first of all, what is an increasing and decreasing function? So an increasing function is basically a function in which the y values increase as the x values will increase. And a decreasing function is the opposite of that, where the y values will decrease as the x values will increase. So here I'm going to show you what I mean by that. So for example, let's take a look at the graph we have over here. We're going to look at the left side of the graph, this part. Now for example, what we are going to do is take any 2 points of the graph. So for example, let's see -2 and 4, and let's take -3 and 9. Let me write out the points: -2, 4, -3 and 9. What I'm going to do is basically find the gradient of this line, and that is going to help me determine whether it is an increasing or a decreasing function, even though you can directly see it that as we went from the x value of -3 to -2, the value of y decreased by 5 from 9 to 4. So this is basically a decreasing function. You can see from that, or you can find the gradient of the graph. So let's see 9 minus 4. The gradient, we are using y2 minus y1 over x2 minus x1. So -3 minus minus becomes plus 2. So this gives me 5 over -1, which is -5. So if you look at this gradient, this is less than 0. So from this you know that it is a decreasing function till here, and then after that you can also take any 2 points, for example 2, 4 and 3, 9, and do the same process. You will get the gradient as positive 5, which is greater than 0. So from these two facts you can conclude that if m is less than 0, it will be a decreasing function, and the opposite is also true. If m is greater than 0, it will be an increasing function. And as you already know that m is equal to dy over dx. So if you come to the right side, this is a picture taken from the Cambridge book. You can look at it that it is going from a decreasing function to an increasing function, and at the point a and b it is stationary. We are going to discuss that in a moment. So let's check on the question. Alright, so here we have a question. Find the set of values of x for which y is equal to 8 minus 3x minus x square is decreasing. So we need to find the values of x where the function is a decreasing function. So what is this supposed to mean? It means that m is less than 0 or dy over dx is less than 0. We are going to use this fact. Now let's see what is our dy over dx. Y is equal to 8 minus 3x minus x square. So dy over dx should give me minus 3 minus 2x. And as we know dy over dx is supposed to be less than 0, we can keep this less than 0. Minus 3x minus 2x is less than 0. Now let's take minus 2 over to the other side, is less than 2x. So minus 3 over 2 is less than x. This is how we are supposed to find the answer to this question. So now let's move on. So now we have second derivatives. Second derivatives can also be known as double derivatives. So basically these are just the rate of change of gradient or the rate of change of dy over dx, and these are used to find the nature of points, basically to know if a point is a maximum or a minimum point. We are going to get to that in a second. So first of all, for example, let's say I have an equation y is equal to x squared. The first derivation dy over dx is going to give me y is equal to 2x, dy over dx is equal to 2x, and the second derivatives, which is known as d square y over dx squared, this is the notation for the second derivation, is going to give me 2. So you just derivate it again. This is basically what second derivatives are, and now let's discuss how they are used. So here we have stationary points now. So stationary points are simply points where the gradient dy over dx is equal to 0. So for example, on the left hand side graph, you can see the points P, Q and the point R. The gradient is equal to 0. These are known as the stationary points or the turning points. And as you can see, they are occurring when between an increasing function and a decreasing function. So but it is not only limited to this, because as you can see on the right hand side graph, we have another type of stationary point where dy over dx is greater than 0, then it goes to 0 and then it becomes greater than 0 again, and then on the other side you can see it becomes from negative to 0 then negative again, and these points are known as the points of inflection. Let's move on to the maximum points and the minimum points. So here we have the maximum point and the minimum point. On the left hand side of the graph, here we have the maximum point, and on the right hand side we have the minimum point. Max as in the highest value and minimum as in the least value, as we already know. So these points only occur when the dy over dx is equal to 0, or basically the gradient is equal to 0. Now let's discuss the next value. So it occurs when a function goes from an increasing function, so gradient is increasing and then the gradient goes to 0 and then the gradient is less than 0. You can write it as m also, but alright. So and the minimum value occurs when the gradient goes from decreasing function to 0 and then to an increasing function dy over dx greater than 0. So we are supposed to relate this concept with the concept of second derivatives. As you already know, second derivatives are known as the rate of change of gradient or the rate of change of dy over dx. So let's discuss the overall change on the left hand side graph. As you can see, I've circled it. So what is the change happening? You can see the gradient is going from a positive value to a negative value, positive to a negative value. So what does this mean? This means the overall decrease of gradient is supposed to be negative. Means that the rate of change of gradient d square y over dx square is less than 0. This is what it means, and this is when the max point is supposed to occur. So for the max point, let me write it up here. Dy over dx is supposed to be equal than 0 and d square y over dx square is supposed to be less than 0. Now let's discuss the one on the right hand side. So as you can see, the gradient is going from a negative to a positive value. So the gradient is increasing gradient. As you can see, the x values increase, the y values increase, so the d square y over dx square is supposed to be greater than 0. The rate of change of gradient is supposed to be greater than 0. So for this you can write dy over dx is equal to 0 and d square y over dx square is greater than 0. These are the things you will be using for maximum and minimum points. This helps us describe the nature of a graph. If your second derivative is greater than 0, then it is a minimum point, and if your second derivative is less than 0, it is a maximum point. You need to remember this. Or simply you can also check it with if a point is coming in between an increasing function and a decreasing function, then it is a maximum value, or if it is coming between a decreasing function and an increasing function, it is a minimum value. So it is basically just common sense. Alright, now let's move on. So now we are going to discuss the rate of change. Basically the rate of change is just any variable with respect to time. So for example, dy over dt or dx over dt, I can write any variable with respect to time. So dt should come in the denominator for this rate of change, and in this chapter we use the chain rule. As you can see on the right hand side, we have used dy over dt is equal to dy over dx into dx over dt. So we are going to solve a practice question so this becomes more clear to you. What we are trying to find, the rate of change is only supposed to be with respect to time. Remember that. So for example, let's say this dy over dt is known as the rate of change of y, or the rate of change of y with respect to time. Alright, now let's solve the question. Alright, so here we have the question. A point with coordinates xy moves along the curve. Let me write the curve over here, x plus square root 2x plus 3. Alright, in such a way that the rate of increase of x has the constant value 0.06 units per second. Alright, so as we know, it says the rate of increase of x. So this means it is going to be a positive value and it is going to be dx over dt is equal to 0.06. Alright, now find the rate of increase of y at the instant when x is equal to 3. We are supposed to find dy over dt when x is equal to 3. Alright, so first of all, we are going to differentiate. Let's see what we are supposed to find is dy over dt. So how are we supposed to rearrange this? So we get dy over dt. So if you look at it, I can write it like this: dy over dt should be equivalent to dy over dx into dx over dt. So from this, you know, this and this will cut out, so I will get dy over dt. Alright, so now let's discuss how are we supposed to find this. So first of all, dy over dx, as you know, so we can differentiate this directly. Y is equal to 1 plus 1 over 2 into 2x plus 3 into minus 1 over 2 into 2. So this is going to give me y is equal to 1 plus 1 over square root 2x plus 3. This is one of the ways to do it. This is basically the chain rule. We are differentiating the inside and multiplying it by the differentiation of the outside. Alright, so or if you don't understand, I'm going to use the chain rule over here. So let's see the chain rule. We can see u is equal to 2x plus 3 and x will be u minus 3 over 2. Alright, so now we can rewrite it in terms of u minus 3 over 2 plus u raised to the power of 1 over 2, and now we can find dy over du. First of all, let me rearrange it a little more. 1 over 2u minus 3 over 2 plus u raised to the power of 1 over 2. Alright, so now dy over du should give me 1 over 2 plus 1 over 2, and u should be minus 1 over 2, so it should go in the denominator with square root u. This is u. Alright, so we have our dy over du, and now let's see du over dx. Du over dx is simply 2. So to find dy over dx, we are just supposed to multiply dy over du with du over dx. As you can see, the du is once in the numerator and once in the denominator, so it will cancel out either way. So 1 over 2 plus 1 over 2 square root u into 2. This is supposed to give me 1 plus 1 over square root, and the 2 and 2 will cancel out here too, so the square root u is supposed to be 2x plus 3. So as you can see, this can be proven from both sides, but the differentiation of the inside multiplied with the differentiation of the outside is a very fast method. Alright, so now let's move on. What we have is dy over dx. We have found that. So now we can just input it over here. Dy over dt is equal to dy over dx into dx over dt. So 0.06 into, and it says when x is equal to 3. So you are supposed to input x is equal to 3 into the dy over dx equation you got. So 1 plus 1 over square root 2 into 3 should give me 6, and 6 plus 3 should give me 9. This is how we are going to write it out. So this is supposed to be 0.06 plus 0.06 over 3. Let me just solve it from the calculator. So 0.06 plus 0.06 over 3, this gives me 0.08 as my final answer. This is going to be your dy over dt, or the rate of increase of y. So as you can see, this value is positive, it is greater than 0. This means that the gradient is increasing, which means that your y coordinate is basically increasing. Increasing gradient equals to increasing y value, as you can see. Alright, let's move on. So now let's discuss an important fact. This thing came in the paper 9709 May June, paper 12 2023. Alright, you can check out the paper. It was the last question of the paper. The students couldn't figure out the fact that tan theta is equal to m. So now let's see, what is m supposed to be. M is supposed to be change in y over change in x, and the tan theta is supposed to be equal to, as we know, TOA, TOA. Tan theta is equal to opposite over adjacent. So now let's draw a right angle triangle, something like this. Let's say this is the right angle triangle, and this is supposed to be your angle theta. In front of your angle theta is supposed to be the opposite, and this is supposed to be your hypotenuse, and this is supposed to be your adjacent. So as you can already see, your adjacent is equal to the change in x, and your opposite is equal to the change in y. And now when you put it over here, you get change in y over change in x, which is basically equal to m. Students couldn't figure it out, so I thought I will discuss this fact. Alright, so this is the end of your differentiation series. And now we are going to continue with integration.